Lesson 10, I will solve multi-step measurement word problems. Today you're going to need your problem set, and I'm going to be allowing you to solve some of these word problems by yourself, and then we're going to be checking together. You will not be doing anything in your journal today. Okay, so this is problem 1. We're going to use the RDW process. We're going to read, draw, we're going to write a number sentence, and we're also going to write a word sentence. So Paula's time swimming in the Ironman triathlon was 1 hour 25 minutes. Her time biking was 5 hours longer than her swimming time. She ran for 4 hours 50 minutes. How long did it take her to complete all 3 parts of the race? So does this sound like a total or does this sound like a comparison? It kind of sounds like both, doesn't it? It sounds like we're creating a total or finding a total, but I also hear some comparison words. Like right here where it says her time biking was 5 hours longer than her swimming time. That tells me that if I create a tape diagram that compares her swimming, her biking, and her running, then I could be able to find the total. Okay, so let's start with our tape diagram. So we're going to have her swimming time. So we're going to put swim, and then we're going to draw our tape diagram here. And how long did she swim? 1 hour, 25 minutes, right? Then it says that her biking time was 5 hours longer. So this is going to be, actually it would be much longer, but I'm not going to be able to do it the actual size, but it's 5 hours longer. So we don't know how long this is. All we know is that it's 5 hours longer than her swimming time. So this distance past her swimming time is going to be 5 hours. And then her running time was 4 hours, 50 minutes. And we're trying to figure out how long did it take her to complete all 3 parts. So this will be our question mark. So I want you to take a look at this tape diagram, and I want you to think about how would you solve this problem. And I want you to try to find the total all by yourself, and then we're going to come back and we're going to discuss your results. Okay, so hopefully you solved this all by yourself. I'm just going to walk you through really quickly how I solved it. The first thing I did is I figured out that if she biked for 5 hours longer than she swam, then all I had to do was add 5 hours to 1 hour and 25 minutes, and that gave me 6 hours, 25 minutes. Then I decided, well, if I'm going to find a total, then that means I need to add. So I went ahead and wrote down this addition sentence. I added her swimming time, her biking time, and her running time. And all I did was add hours to hours, and that was 11 hours, and minutes to minutes, which was 100 minutes. And then I decomposed this 100 minutes into hours and minutes because I knew 60 minutes are in an hour, and that would leave 40 minutes left over. So then I added this hour to 11 hours, and that gave me 12 hours, 40 minutes. So I just completed this by writing my sentence. It took Paula 12 hours, 40 minutes to complete the race. All right, so let's take a look at problem number 2. Nolan put 7 gallons, 3 quarts of gas into his car on Monday and twice as much on Saturday. What was the total amount of gas put into the car on both days? Okay, so is this a comparison problem or is this a total problem? Well, again, I'm hearing some comparison words. I'm hearing twice as much. Okay, I think that this problem is simple enough that you could go ahead and pause the video and do all of this by yourself, and then let's come back and discuss this and see if we have the same answer. Okay, so hopefully you did this problem by yourself. So let's start taking a look at our model first of all. So this was my model. Here was the amount of gas that he put in his car on Monday, and then on Saturday he put twice as much. So I put 2 times the same amount, and then here's my total. So when I got ready to come up with an addition sentence or a number sentence, I thought, well, I could add. I could say 7 gallons, 3 quarts plus 7 gallons, 3 quarts plus 7 gallons, 3 quarts. But since all of these are the exact same number, I chose to use multiplication. And I did 3 times 7 gallons, 3 quarts. Then I used the distributive property, and I said 3 times 7 gallons plus 3 times 3 quarts, which equals 21 gallons, and 9 quarts. So since there are 4 quarts in a gallon, I decompose that 9 quarts into 2 4 quarts and 1 quart because each of these 4 quarts is equal to a gallon. So that gave me 23 gallons and 1 quart. So I went ahead and wrote my sentence. Nolan put 23 gallons and 1 quart of gas in his car. Okay, let's take a look at problem number 3. One pumpkin weighs 7 pounds, 12 ounces. A second pumpkin weighs 10 pounds, 4 ounces, and a third pumpkin weighs 2 pounds, 9 ounces more than the second pumpkin. What is the total weight of all 3 pumpkins? So this problem is set up pretty much like what we did in problem 1. I want to see if you can't go ahead and use the RDW process on this problem all by yourself, and then we're going to come back together at the end and we're going to check together and see if we got the same answer. Okay, so hopefully you solved this problem by yourself, and let's start with our model. So here's what my model looked like. I went ahead, I knew how much the first and the second pumpkin weighed, and I knew the third pumpkin weighed 2 pounds and 9 ounces more than the second pumpkin. So to get the weight of the third pumpkin, I just added 2 pounds and 9 ounces to 10 pounds and 4 ounces, and that gave me 12 pounds and 13 ounces. Then to find the total weight of all 3 pumpkins, I added them all together. So I just added pounds and pounds and pounds, and that was a total of 29. And then I added all of the ounces, and that was also a total of 29. So then I decompose this 29 ounces into 16 ounces in what was left over because there are 16 ounces in a pound. So that gave me a total of 30 pounds and 13 ounces. So I wrote my sentence. The pumpkins weigh, this should be weigh instead of weight, weigh a total of 30 pounds and 13 ounces. All right. Problem number 4. Mr. Lane is 6 feet 4 inches tall. His daughter Mary is 3 feet 8 inches shorter than her father. His son is 9 inches taller than Mary. How many inches taller is Mr. Lane than his son? Okay, so I'm hearing some more comparison words, aren't you? What you're going to have to really be careful here is that you understand that in all the other 3 problems, the question has asked for a total. This is not asking for a total. This is asking for how many inches taller is Mr. Lane than his son. I want to see if you can figure this out all by yourself, and then we're going to come back together and see if we got the same answer. Okay, so first of all, I drew my model, and I knew that Mr. Lane was 6 feet 4 inches tall. I didn't know how tall Mary was, but I did know she was 3 feet 8 inches shorter than her dad. So I subtracted these two to find that Mary was 2 feet 8 inches tall. Then I knew that the son was 9 inches taller than Mary. So I took Mary's height and I added 9 inches, and I got 3 feet 5 inches. Now to find how much taller Mr. Lane was than the son, I had to subtract their 2 heights. So down here is my work. So this is where I took Dad minus Mary's weight, or height, and then I figured out that this is how tall Mary was. And then I took Mary's height, and I added 9 inches, so this was Mary, and then I added her brother's height, and this is how tall the son was. So then to find out how much taller Dad was, I had to subtract. I had to take Dad's height minus the son's height, so I ended up with the dad being 2 feet 11 inches taller than the son, so that's what I wrote my statement as. Mr. Lane is 2 feet 11 inches taller than his son. Okay? All right, so today we did some problem solving. So I hope that you understand how drawing this model will definitely help you to be able to solve the problem. It's really important to always go back and think, does my answer make sense?